Hello guys, my name is Tu. In this video, I'll be demonstrating on how do we extract some specific parameters from a flow simulation using the NX software. So to begin with, I have a set of work files, example work files. So I will show you the .prt file, which consists the basic geometry for the simulation model as such. Moving forward, I will show you the .fem file that consists the mesh and also the property of the mesh information. So as you can see, the mesh is simply hexahedral for faster convergence and computational time. To quickly show you the properties of the mesh is indicating, the property indicates that the material is air. Moving forward, I will show you the .sim file that consists of the boundary condition for the simulation. So this will be the solution number 1. The setup is already contained 3 definitions. The first definition will be the inlets as highlighted at this surface. So in order to show the surface more clearly, I will turn off the display of the mesh momentarily. And I will double click on each of the nodes to show you the definition. For example, the inlets, as you can see, the card name is inlets. So the highlighted surface indicates that air will flow into the fluid domain with a velocity magnitude of 500 millimeters per second. Moving on, we'll look into the outlet definition. The outlet is simply an opening card or equivalent to a pressure outlet with reference to the external ambient condition. Next, we'll look into the report predefined. The report is defined between the primary region at the highlighted surface here, which is the inlet, and also the secondary region at the outlet surface. And between the regions, I would like to report on the pressure drop values. And you can notice the card name is called report between regions. Furthermore, you can try to create additional definitions on the report. So we can move to the simulation object types and find the report command. Click on the report command, and this time, instead of using between regions, I would like to choose per region because I would like to report some specific parameters which is per region. For example, I would like to report on the mass and volume flow. I will put a check here, and for the name, I will put a more meaningful name, for example, inlet mass flow rate. Choose the inlet surface here and click apply to accept the definition. And after clicking apply, notice that there is a 4th definition at here. Now we'll try to create another report which is called the outlet mass flow rate. Choose the region at this surface here, check on the mass and volume flow rate settings and click OK. So these two reports will will give us additional results, which is the inlet and also the outlet mass flow rate. So finally, I've finished all my definition and I'm ready to solve. But before I solve, I would like to show you some of the settings here in the simulation edit setup. We'll go to the simulation edit. In order to keep my files more organized and more structured, I will choose to change the default run directory from current simulation to simulation solution name. By doing so, some of the end result file will be put into a separate folder. The folder name is governed by the simulation and dash solution name, which is solution 1. So the next thing we'll look into is the ambient condition. For example, the gravity is defined in the negative z direction as such, and also the ambient condition. Click OK, and we are now ready to solve. Right click on solution 1 and choose solve. Click OK to solve the simulation. Notice that the solving progress is now begin, and we can quickly check on the convergence graph, and the solution is now solved in no time. Then we can click on the close button to turn off the additional dialog box. Now notice that in the working directory we have some of the important files, such as the .bun file, which represents the result files at this location here. So if the BUN file exists, then we can double click on thermal flow node here to show the results, the contour plot results. So we can try to expand the thermal flow node here, double click on the velocity node to show the velocity results overall. Static pressure contour plot, total pressure contour plot, and so on. So this additional folder contains additional information from the solving. So this information will be used for subsequent analysis or operations, such as a restart analysis. So we can try to do additional operation from this particular folder. But this bound folder is more relevant to the user because it contains the results. And finally, let's look into, because we have predefined the reports, so where do we get the report information after the solving process is complete? So this information is actually stored inside the HTML file. So this HTML file is actually can be opened by using a web browser. For example, we can use the Google Chrome web browser to open this file. So let's say we double click on this file, and it will give us, as you can see, the report for the inlet mass flow rate is written at this location. So does the outlet mass flow rate. So in order to make sure that the solution is accurate, we need to check that the inlet and the outlet mass flow rate is almost identical in order to preserve the mass equation. Next, we can look into the pressure drop. So this pressure drop defines the static pressure at the inlet of the static pressure at the primary region and the static pressure at the secondary regions. And the static pressure drop is simply a reduction between the pressure between I and J. And also we can have the total pressure I, total pressure J, and the total pressure drop as such. So if you're wondering what are the units for the pressure drop, it is all written at the top location here, and this unit is equivalent to kilopascal. The mass flow rate is having a unit of kilogram per second. So that's it for this short video. I hope you enjoy it. Thank you very much.